Okay, so we're naming right now all the different toppings on a Wendy's hamburger and see if there's 256 ways to personalize your hamburger. Okay, so we've got ketchup, we got mustard. What else we got? I got onion, pickles. I got tomato, mayo. Okay. All right. So let's say we got those 9 options. What do we think? This is, I'm going to tell you right now, 256 ways. They used to have this on the Wendy's bag. There are 256 ways to make your personalize your hamburger. Good thing we have math teachers, and then math teachers went through and figured it out, and it was wrong. Okay, so we're going to figure it out. So 256 is not right. Do you think there are more than that or less?
Less.
Who thinks there's less than 256 ways? Who thinks there's more?
A lot.
Okay, so we're about even.
Yeah.
So more, less, we're about even. Class is split. You write down which one you think. You write down more if you think it's more. You write down less if you think it's less. How many different ways do you think there is to personalize a Wendy's hamburger? So we're just going to make a prediction. How many ways do you think we can personalize it?
Yeah.
You guys say 150. Anybody else?
Maybe 175.
You think 175? Somebody thinks 350? Anybody else have another one? 212? Okay. We've got all the different toppings up here. We listed them. Okay. So I said some people can put more, some people can put less. Okay. We're going to calculate. We got to figure out if this is a combination or a permutation.
How would you figure that out?
All right. Well, remember, permutation order matters.
Oh, yeah.
Combination, it doesn't. So if you're making a hamburger, does the order matter or not?
Yeah. They got to be stacked, right?
Now, if you tell the people that I want a hamburger with cheese, lettuce, and tomato, are they going to ask you which way you want it put on there?
But like, they got like a board, you got to like follow it.
But are you going to tell them how you want it?
Because they're already going to put it the way most people want it.
I'm going to tell you right now, they're asking you how many toppings you want in it. I don't think order is going to matter. Is it all going to be in the same bite when you bite it?
Yeah.
Okay.
So it's combination.
So I personally think this is a combination. Okay? See how it's hard to tell? See how we had a lot of issues with it? It's like this too. If I'm like, okay, how many people in this class? We've got a class of 29. If we need 4 people to be on a committee, what do you guys think that is? A combination or a permutation? 4 people on a committee out of this class.
Combination, because it's just people. It don't matter what it is.
So if I have 29 people in the class, I need 4 people to be on a committee. Does it matter the order they're in?
No.
So let me ask you this question. If Aaron, Emmanuel, Kayla, and Christian are on one committee, does it matter? Is this a different committee?
No, it's the same.
It's the same committee, so this is a combination. Okay, now what if I said we have to elect somebody for president, vice president, secretary, and treasury? Now it's a permutation. You got it.
Because it's like,
Because it's different. If you're the president, that's different than if Manny's the president, right? Okay. So, we're going to say it's a combination, but what's the formula for combinations again?
N
Factorial
yeah, factorial.
over.
R factorial times N minus R factorial.
Good. What's the formula for permutations, though? N factorial over N minus R factorial. Okay? One has that extra R in the bottom, the other one doesn't. Combination has that extra R. Okay, here's my question. Could I have all 9 toppings on my burger?
Yeah, but it would be a fat burger though.
Yep. but I would have all 9. Could I have 0 toppings on my burger?
Yeah, it's gonna be dry.
All right, this is starting to get complicated though, guys. Okay, I can have all, I can have none. All right, so let's try this.
So we would do
How am I going to do this then?
256 over.
No, not 256, because that's a number I don't know. I have 9 different
Oh, 150?
options.
The number we picked.
So,
You put 9 on top, it's 3.
okay, so if I put 9 factorial,
But I thought it
and then I have this space, I have to put something here. This is still 9 minus whatever goes here, factorial. So the problem is, R is the number of options I'm going to choose. But I could choose 0, I could choose 1, I could choose 2, I could choose 3. So it changes. What does that mean I got to do? It means I've got to do it 10 times.
I was going to say that. I didn't think it was
Okay? So, because we could have 0. Remember, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8. Because there's only 9 options, right? So I've got 9 options, plus I could have nothing on it. So now I have 10 options. Yeah? So I could have, and I'm just going to write this as 9 combination 0, 9 combination 1, 9 combination 2, 9 combination 3, 9 combination 4, 9 combination 5, 9 combination 6, 9 combination 7, 9 combination 8, 9 combination 9, and 9 combination nothing. Because we have 0, so we don't have 10 different options. Okay.
Huh?
Right. Can't do 9 combination 10. There's no 10 I can do. You're right.
Why is there not a 10?
Because there's not 10 options, because I only have 9 options. 9 combination 10 would be, I'm going to choose 10 of the 9. That doesn't make sense. Okay. So, what is 9 combination 0? You can either put it in your calculator, you can go to menu, probability, choose combination and just go 9 comma 0, or you could do 9 factorial over 0 factorial times 9 minus 0 factorial. That's why we're going to do that. Okay, so who's got a calculator in front of them? Okay, so 9 factorial, 9 combination 0 is 1. What's 9 combination 1? Who's going to do the next one?
Where's the comma on
Who's got it? Who's got the answer?
9?
9, good.
So you just multiply?
What's 9? We'll try 9 combination 2, because I think you're going to get a different answer. 9 times 0 would be 0 anyways. 9 combination 2 is not 18. What do you get? 36. What's 9 combination 3? I don't. I have the answers written over here. I would have to put it in my calculator too. No, I do not. I am not able to do any of those in my head.
84.
84. 9 combination 4. $126. 9 combination 5.
122.
We get 126 again, yep. 9 combination 6. What do I get for 9 combination 6? 84.
So we're just gonna go to the 9 7, right?
What's 9 combination 7? I get 36, right?
Yeah.
9 combination 8, I get 9.
But I knew it didn't go back.
And 9 combination 9, I get
1.
1.
I
Okay,
was going, but like, why did it stop at 126?
why did it stop at
Is
126?
that, oh, is that the? Oh, that's
So remember, we've got, for 5 and 4, so we've got 4. We've got 9 possibilities, 9 possibilities, 9 possibilities, and 9 possibilities, right? For 5, we also have 9 possibilities for them. So it ends up being the same thing for these. Because they can go in any order, because it's different if you have lettuce, tomato, onion, or tomato, onion, bacon, or whatever. So I think the correct answer when I say why does it go back like this is I don't really know the answer to that. I think I will have to look that up. I thought I could do it and this made sense, but it does not. So my explanation over here does not. I will have to check on it. Okay, so now you're going to add all those things together. And what do we get?
We got the 126.
So 1 plus 9 plus 36 plus 84 plus 126 plus 126 plus 84 plus 36 plus 9 plus 1. What do I get? You guys can add 10 things together. Take out your calculator, plug it in. Let's do this. 1 plus 9. You're typing 10 things into your paper. You're fine. To your calculator. I guess you're not typing it into your paper.
Only 512?
You get 512 ways. There are 512 ways. Okay.
So it was more than.
So, we're not going to do number 8 and number 9, but I want you guys to think about it. This is for a single burger.
I want that triple.
How many are more if you could do a double or a triple?
I double, so it's just double the weight.
But if it's triple, yeah, it's just times 3. So times
But-
that by 2.
So you're looking at, you have 512 ways for a single. For a double, you think you have another 512 ways?
Oh, no, it's the same. It's still the same burger. Still the same burger with the same.
Versus triple?
Because it's really just an extra package.
Yeah, to be honest.
But if your choice was, you have 512 ways for toppings, but one of your choices is also a single, double, or triple. So then are we adding 512, 512, 512?
No, just one. Right?
I'm going to let you guys think about that. Okay, so we are going to move to your homework for today. And we're going to go over a couple of different ones of these so you don't have to do all of this on your own.
You ain't got the calculator to do it.
So what you're going to do for most of these is if you don't have a calculator, you still have to set it up. So I need to know like if it's a permutation, combination, that kind of a thing. That's more what you're doing for your homework, but I do want to do some of these together.
So do we got to say what it is or we just start working?
Either. Okay. So, can everybody do 5 factorial in their calculator? Now 5 factorial you do not need a calculator to do, right? Because I could just go 5 times 4 times 3 times 2 times 1, correct? So I could also hit in my calculator 5. The factorial button is right underneath the enter by the question mark. So 5 factorial, we get 120. What about number 2? So you could put that all in your calculator. It is 90, but you could put it all in your calculator at once by hitting the control divide button. If you hit the control and then divide button, it comes up and you can go 10 factorial over 8 factorial. And that ends up giving you 90, yes.
So that's 84 from the 3.
Mm-hmm. Okay. Now,
Usually wait till that quiz.
you need to evaluate these. I suggest you do A, B, and C before you leave so that you don't have to do it. You just hit your menu again, probability, permutation, 7, 4. It does it for you, get 840, right? Okay. These ones should be pretty simple. You're just putting this stuff in your calculator. Now we're doing the ones where you have to actually evaluate it. And I'm just going to do, like, figure out what it is. So I've divided these up into the first 15 are permutations and 16 through 21 are combinations. But let's make sure we've got this, okay? 5 says,
What we got to do?
shh,
Flip back?
yep.
Oh,
5 says, in how many different ways can 7 floats line up for a homecoming parade? How many different ways can 7 floats line up for a homecoming parade?
So 7 times.
Okay,
But we don't know.
so is this a permutation? Is this just counting principle?
Yeah.
Is this a combination?
Combination.
Yeah, it's combination.
Combination, right?
Combination. So you guys would be okay if at your homecoming parade, seniors came first, then sophomores, then freshmen, then juniors. So order matters, okay? Because that's a different thing than freshman, then sophomore, then junior, senior.
0.
Okay. So there's 7 different ones, and order matters. So this one's pretty straightforward, where we got 7 spots. 1, 2, 3, 4, 5, 6, 7. So how many different options do I have for the first one? How many for the second one? Oh, then the next one? 5, 4, right? So that's just the same thing as 7 factorial.
See, I knew that. That's Oh, you're big.
So 7 factorial is 5,040. Okay? So if there are the same number of places, because there's 7 places and there's 7 floats, you just do 7 factorial. Now for number 6, it's how many ways can 4 of the 7 kinds of bushes be planted along the highway?
So 7 and
Walkway.
4.
Yeah.
I was right.
Okay. So if we have, hold on, I'm going back to 5. You guys think about 6 for a second. I'm going back to 5. So there's 7 possible floats for the first option, right? But once you use one of them, you cannot repeat that float. Correct? So once like the freshman float goes by, the next one can't be the freshman float, right? So we go 7, 6, 5, 4, 3, 2, 1. So after each float goes by, you only have 6 options for the next one because we used one. We only have 5 options. So 7 times 6 times 5 times 4 times 3 times 2 times 1 is the same thing as 7 factorial. Yes. Which is 5,040. Okay, so let's talk about the next one. So let's look at this. Shh. We're figuring out if it's permutations or combinations, okay? In how many ways can 4 of 7 different kinds of bushes be planted along a walkway? Order doesn't matter. So if you've got a maple tree, and then you've got a rose bush, and then you've got a maple tree, that's different. That's the same thing as a rose bush, maple. It's not different than a maple, rose bush, maple. Doesn't it look different? So then it matters. I get what you're saying. But look, if I got a tree, a bush, a tree, that looks different than a bush, a tree, a tree. Hey, I don't make fun of your drawings. Okay, so these are 2 different things because it ends up being different. That's why it's a permutation. This is why it gets hard. So for a permutation, you're just going 7P4. So you're literally going to your calculator, menu, probability,
Where did the P come from?
because it's a permutation because order matters. So we decided it went there.
So when there's a permutation, you gotta do it like that?
Yep. We get 840. Let's turn it over. I want to do at least 1 on the back.
You just put 7 and 4 in?
Yeah. And so you can't do that on your homework, right? So just do, like if you just have this, you get full credit for your homework. Okay? We'll enter these when we get to school. Okay? Let's turn it up. We're going to do all of them. Okay. We're looking at 16 on the back. Shh. Your friend is having a party with 15 games to choose from. There's enough time to play 4 games. And how many ways can you choose the 4 games? Combination or permutation? Combination, because you're just choosing 4 games, right? So that means you have that C for combination. There's 15 games, and you're going to choose out of 4. How many games do you guys have at your house? I have way more than 15.
Board game?
Yeah.
I mean, I don't get probably 0.
I have like 200.
I probably got them in the garbage.
For real, I have like 200 board games at my house. I like to play board games. Monopoly is a board game. You don't have Monopoly? My husband's obsessed. We play board games at least once a week. We have grown-up board game night and we have board game night with the kids. Grown-up board games is when we go to our friend's house and we play board games. Okay. All right, I need you to be quiet in 5, 4, 3, 2, 1. Yes, Abby.
So it's like the same thing with P, you know, like
Yeah.
you see it and then it's a different calculator.
Yes. So permutations are always bigger because order matters. Combination's going to be smaller. So what I'm looking for your homework is you just to write these things out. And there's too many problems on this page for you guys to do for homework, right? Let's do the evens.
Good. Go back to that bag.
I will go back to the back, but you guys just have to do the evens. And I'll change it on my website and everything.
So we did number 5 for no reason?
Yeah. Just, well, I didn't decide until after we were done, sorry. All right, so just do the evens. I could give you all of them, we could change it. Okay, okay, let's just do the evens.